In this video, I want to walk you through step by step how to prove via the Epsilon-Delta definition of a limit, how to show that a limit equals some number. Okay, so in general, we start with scratch work and then we finish with what's known as the formal proof part. So I'm going to show you the formal proof. That's the finished product, but in order to get that, we do the scratch work. So with the formal proof, what do we want when we write up our final answer? We want to start with an x minus c. Now look, this is for the limit as x goes to c of f of x equal to some number L, okay? So that's my limit definition. So x minus c, that comes from right here, x approaches c of f of x, okay? And we want that absolute value, the distance between x and c, to be less than delta. Okay, that's my fixed delta value, that distance between the x and the input c. And then once we have this here, we conclude that f of x in absolute value minus L is less than epsilon. And that's the final conclusion there. So with the formal proof, we start here and we finish here, okay? Now, how do we get that? We get that through the scratch work, okay? Sometimes it's easier to work a problem backwards than to work it straight forwards going through. And that's the case when you're proving using the Epsilon-Delta definition. We want to start backwards. We want to start with the end result, what we want to conclude with, and then work our way back to this delta something, okay? And so how do we do this with the scratch work? So on your test, I want to see scratch work, and I also want to see your formal proof, okay? So you start with the conclusion, f of x minus L, so you take the function, whatever it is, x squared, 3x plus 1, whatever, and then minus the limit, what it equals to when you take the limit, an absolute value less than epsilon. And then what do? You perform some algebraic manipulation to give the inequality in the form of x minus c. Remember, we're trying to get back to this point here. So the formal proof goes in the opposite direction as the scratch work does, okay? So the scratch work goes this way and the formal proof goes this way, okay? And so we're working it backwards so that we can then rewrite the steps in the opposite order to get our answer, okay? Now, this x minus c is going to be less than something, and that's the thing that's so cool about the formal proof is we just say, hey, by the way, here's the something, and you're like, wow, how did you pull that? Did you pull that out of a magic hat or something? How did you get that? Well, that's the point in having the scratch work so that I can see how you actually got your delta, okay? So that something is in terms of epsilon. So maybe it's like epsilon over 7 or something like that equals delta. But it has epsilon in terms of it, okay? So we're going to prove that the limit as x goes to 2 of 3x plus 1 is equal to 7. How do I do that? Well, let's walk through the in general here. So I'm going to start with this right here. So how do I get this? So it's f of x. My f of x is 3x plus 1. Okay, so I have 3x plus 1. Okay, and then I do minus L. Okay, minus L. So my limit is L. So minus L. And then that's less than epsilon. Less than epsilon. Now I want to use some algebra to manipulate it down to this. So that part right there is x minus, well, what is my c here? The c happens to be 2. Okay? So x minus 2 less than something. Okay? And that something is equal to delta. Now, let's see if we can manipulate this to make it look like this right here. That's what we want. That's the goal. So if I simplify, I have 3x plus 1 minus 7. So 1 and minus 7 make 3x minus 6. Okay, this is looking good. How can I turn 3x minus 6 into x minus 2? Well, I can factor a 3 out of this, and I have 3 times x minus 2. Now, all these are less than epsilon here. Okay, and so I have 3 times, I'm going to take that 3 out, x minus 2, an absolute value. Okay, and so I'm right there. The only thing I've got to do is I need to get rid of multiplying by 3. And so how do I do that? I just divide both sides by 3. Okay, don't get confused with the 3 and the e. Those are two different things, right? Okay, so now I've done exactly what I wanted. I wanted to get something in terms of epsilon, so that this was greater than this x minus 2 factor right here. That was the goal. Okay, so I've done that. So this is the scratch work. Okay, so I'm going to label this scratch work over here. So just put it over to the side. Now I've got the formal proof. So how does the formal proof work? Well, what do? We start with the inequality right here, x minus c less than delta. So I'm going to say what? I'm going to say x minus 2 less than delta, okay? And then I want to conclude with this right here, all right? So what am I going to say? Well, I'm going to say that delta is equal to, well, what did we say delta was equal to? Epsilon over 3. So x minus 2 in absolute value is less than epsilon over 3, since delta equals epsilon over 3. Okay, that seems to be fair enough. And so now, what did I do here? I literally, the scratch work took me down, so the formal proof is going to take me up to the final answer. So what was the next line? The opposite of dividing is multiplying, so I'm going to multiply both sides by 3. And so I get 3 times x minus 2 is less than, well, 3 times this over here. The 3's cancel. And so this is epsilon. And now what can I say? The 3 comes inside here. So I have absolute value 3 and then x minus 2 less than epsilon. And this is equal to 3x minus 6 less than epsilon. And then this is equal to, well, what is the, we're just going up the line, right? And so this is equal to 3x plus 1 minus 7. And voila, I have my answer, less than epsilon. And if you want, if you really wanted to, you could write f of x minus L less than epsilon here. But if you write this out here and you got your parentheses around it, I know exactly what you're talking about there. Okay? And so in conclusion, you will structure it in this format here. So given epsilon greater than 0, given epsilon greater than 0, choose delta equal to epsilon over 3. Okay. So I choose delta equal to epsilon over 3. And then how else does the format go? Then we say this part right here. Then absolute value x minus 2 less than delta implies, what does it imply? It implies 3x plus 1 minus 7 is less than epsilon. That's literally what we just started with here. We said we started here in our formal proof and we got down to right here. So this thing up top implies this thing down low right here. That's what we're saying. Okay? And if that's the case, then what do we know? The limit is equal to 7. Therefore, the limit as x goes to 2 of 3x plus 1 is equal to 7. That is our conclusion. Okay? So that is everything in one shot for you. Okay? So when I talk about the format, what I mean here is this. Almost every single time, you're going to say given epsilon greater than 0, unless you need to make some weird restriction on epsilon, but it's rare that that happens. And then I'm going to choose delta equal to something, okay? Then I have x less than something, and absolute value is less than delta, implies, and then I have my function less than epsilon. Therefore, the limit as x goes to something is equal to this, okay? And so everything in yellow is always going to be like that, all right? And depending on what you're taking your limit as x goes to, so if x goes to 2, I'm going to put a 2 here, right? I'm going to put the 2 there, okay? If I have my function 3x plus 1, I put the function 3x plus 1 there. And then if I have my 7 here, then I put that 7 there. Now the only thing that we have that's the oddball is this piece right here. And this piece is found through the scratch work. And that is why we do the scratch work first before we do our formal proof. Because that was the whole point of the scratch work, was to get that delta value. And remember, you choose that minimum, that smallest one, and go from there. Okay? So hopefully this gives you a better understanding of how to write up these formal proofs.